Hi everyone, welcome to our physics class. In the previous class, we have studied about two kinematic equations of motion. Number one, that is V is equal to P naught plus AT, and the second one, X is equal to V naught T plus of a T squared, right? So this is a motion along a straight line part 8. Okay, well, let's start today's class. So in this class, we are going to discuss about the next a very important third kinematic equation of motion. So first here, let us consider a VT graph. So what is the meaning of VT graph? A graph drawn by taking taking the velocity that is along y-axis and time that is taken along x-axis. So actually here the particle starting with an initial velocity and moving with uniform positive acceleration. That means the particle velocity changes by equal amounts in equal intervals of time. Okay, let us consider 2 points on a straight line, A and B. So this is origin O. So OA represents what? The initial velocity of the particle, right? So here OA represents the initial velocity, and let us consider so this point as E. What is this? The point E. So OE represents the final velocity. So OA represents the initial velocity, that is V naught, and OE represents the final velocity of the particle. Actually, here OE represents the final velocity of particle. So this one represents the final velocity. OA represents the initial velocity, right? So actually slope of VT graph gives acceleration. Slope of VT graph represents the acceleration. So now let us consider this point as C, this point as T. So OD represents the change in time, that is T. OD represents T, and BC represents the change in velocity. Is it not? BC represents the change in velocity. OA represents the initial velocity. OE represents the final velocity. OD represents the change in time. BC represents the change in velocity, that is V minus V naught. Okay, so here the average velocity is average velocity of the particle, that is V bar. So this is the representation of average velocity. So V bar is equal to, let us consider here, V naught be the initial velocity, V naught be the initial velocity of the particle, and V be the final, V with the final velocity. Okay, so V naught with the initial velocity and V with the final velocity. V naught with the initial velocity. So the average velocity is V plus V naught divided by 2, right? So V naught is the initial velocity, V is the final velocity, the average velocity is V plus V naught divided by 2. So call this as equation number 1. So but the average velocity, so that can also be written in the form of x by t, the rate of change of displacement of the particle divided by time taken. Okay, so x is equal to v bar into t. So call this as equation number 2. Now substitute equation 1 and equation 2. Okay, equation 1 in equation 2. Then we get x is equal to v bar is v plus v naught divided by 2 into t. Okay, but from the first kinematic equation, from the first kinematic equation, first kinematic equation, what is that? V is equal to V naught plus AT. So AT is V minus V naught. So T is equal to V minus V naught divided by A. Call this as equation number 3. Now equation 3 in equation, so call this as equation number 3. So call this as equation number 4. This is equation number 4. Of equation 4, that is in 3. Equation 4 and equation 3. So then we get x is equal to v plus v naught divided by 2 into what is the value of t from first kinematic equation. The value of t is v minus v naught divided by a, right? V minus v naught divided by a. So after that 2ax that is equal to v plus v naught into v minus v naught. So a plus b into a plus b into a minus b, that is a square minus b square, right? So v plus v naught into v minus v naught is v square minus v naught square. 2ax is equal to v square minus v naught square. So v naught square plus 2ax is equal to v square, and finally we will get v square is equal to v naught square plus 2ax. Okay, so this is the third kinematic equation. This is the third kinematic equation of motion, right? The first one is v is equal to v naught plus at. The second one is x is equal to v naught t plus of a t square, and the third one is v square is equal to v naught square plus 2ax. So, and what is the significance of this VT graph. So that is very important for 2 mark, the significance of the VT graph. What is the significance of VT graph? The first one is it gives the nature of motion of the particle. Okay, so VT graph actually represents the nature of motion of the particle. So that is the first significance. What is that? It represents the nature of motion. Nature of motion of the particle. It represents the nature of motion of the particle, and the velocity of particle at any instant can be obtained from the curve. That means the instantaneous velocity at any instant of time can be obtained from the curve that is obtained in VT graph, right? And then acceleration at any instant of time can be obtained from the curve. So after that, slope of VT graph represents slope of VT graph. Slope of VT graph represents what? Acceleration, right? So area under VT graph represents displacement. Okay, so and equations of motion, that means V is equal to V naught plus AT, X is equal to V naught T plus of AT square, V square is equal to V naught square plus 2AX. Okay, equations of motion along a straight line can be derived, right? Equations of motion along a straight line can be derived. So these are the very important uses of VT graph. Number one, it represents the nature of motion of the particle. So the velocity of particle at any instant can be obtained from the curve. Acceleration of the particle at any instant can be obtained from the curve. Slope of VT graph represents the acceleration, right? Area under VT graph that represents the displacement, and equations of motion, kinematic equations of motion along a straight line can be derived. Okay, so these are the some very important uses of VT graph. Okay, the next topic, motion under gravity. So what is the meaning of a freely falling body? It is very important. There's a meaning of a freely falling body. So freely falling body means a body which falls under the action of Earth's gravitational force of attraction. Okay, body which falls under the action of Earth's gravitational force of attraction, that is actually called the freely falling body. So this is the example for motion in one dimension. So here the body is moving along a straight line. Okay, so What is the meaning of freely falling body? A body which falls under the action, a body which falls under the action of Earth's gravitational force of attraction. The force of gravity produces the constant acceleration. The force of gravity actually produces the constant acceleration. So, if a body moving vertically downwards under the action of Earth's gravitational force of attraction, so acceleration of the body that is exactly equal to plus g. So in this case, acceleration of the body that is equal to acceleration due to gravity. So this is the positive acceleration. Suppose if a body that is thrown vertically upwards under the gravitational force, under gravity. So what happens? Actually, the velocity of the body that is gradually decreases. At certain height, its velocity completely becomes zero. So when a body that is thrown vertically upwards under gravity, so its acceleration that is gradually acceleration is constant, but velocity is gradually decreases. Okay, so here we will get A is equal to minus G. So when a body falls under the action of Earth's gravitational force of attraction, so the velocity of the body gradually increases. So the acceleration that is equal to plus G. What is the meaning of G? That is acceleration due to gravity. So when a body is thrown vertically upwards, what happens? The velocity of the body that is gradually decreases. The rate of decrease in velocity of a particle, the rate of decrease in velocity of a body, that is actually the negative acceleration. So that is why your value of A that is equal to minus G. Okay, for vertically downward motion under gravity, A is equal to plus G and the displacement x is equal to h. So here is also displacement x is equal to h. Okay, so when a body is thrown vertically upwards, what happens? Its velocity gradually decreases. The rate of decrease in velocity, that is a deceleration, retardation, negative acceleration. So in that case, A should be taken as minus G and x is equal to h. Okay. So for a freely falling body, the equations of motion that can be written in the form, actually what is the first kinematic equation? V is equal to V naught plus AT. Second one is x is equal to V naught t plus of A t square. Third one, V square is equal to V naught square plus 2ax. Actually, one more kinematic equation is also there. That is the distance traveled in nth second. Xn is equal to V naught plus of A of 2n minus 1. So this is important only for CT. So this is the fourth kinematic equation. Okay, so xn means distance traveled in nth second. Distance traveled in nth second. So that is equal to V naught, that is the initial velocity of the particle, plus of A of 2n minus 1. Okay, so these are the kinematic equations. Okay, for vertically downward motion, for vertically downward motion. The first kinematic equation for vertically downward motion. So what is the value of A? For vertically downward motion, A becomes plus G, right? And X becomes H. So that the first kinematic equation becomes V is equal to V naught plus GT. Okay, right? And the second one, so X becomes H. H is equal to V naught T plus of A becomes G of G T squared. And the third one, V squared is equal to V naught squared plus 2GH. And the last one, HN, distance traveled in n second, that is equal to V naught plus of A becomes here G of 2n minus 1. Okay, so these are the kinematic equations for vertically downward motion, that is under gravity. Okay, so these are the kinematic equations for vertically downward motion under gravity. For vertically upward motion, okay, for vertically upward motion under gravity, so A becomes minus G, X is equal to H. Okay, A becomes minus G, X is equal to H. So the first kinematic equation becomes V is equal to V naught. What is the value of A here? A is minus G minus GT. The second one is H is equal to V naught T minus of G T squared. Okay, so third one is V squared is equal to V naught squared minus 2GH. A becomes G, X becomes H, right? The last one is HN is equal to V naught minus of G of 2n minus 1. So these are the kinematic equations of motion for vertically upward motion. Okay, right? Okay, now let us discuss about a numerical based on motion under gravity. So a ball is thrown upward. A ball is thrown upward and it reaches a height of 90 meters. So find the velocity with which it was thrown. So in this problem, actually, we have to find out velocity with which it was thrown. Is that initial velocity? Is it not? We have to find out the initial velocity. What is given here? Height. Height is given. How much? That is 90 meters. Look at this diagram. A ball is thrown upward. It will reach us a height that is 90 meters. Okay. So if it reaches the maximum height, so at this location, the final velocity of the ball becomes 0. But here, the initial velocity that is not equal to 0, we have to find out the initial velocity, that is velocity with which the ball was thrown, right? So h is the maximum height reached by the Okay, so what is the value of V? Is equal to 0. So H is equal to 90 meter. So how do you find out the initial velocity? By using a third kinematic equation. What is that? V squared is equal to V naught squared plus 2ax. But here the ball is moving vertically upwards under gravity, means A becomes minus G, is it not? X is equal to H. So the equation is V squared is equal to V naught squared minus 2GH. So V squared, that is 0, right? V value is 0. V naught squared minus 2, G is 9.8, H value is 90. So V naught squared is equal to 2 into 9.8 into 90. So V naught squared is equal to, so 2 into 9.8 into 90. 2 into 9.8 into 90. So that is 1764. So square root on both sides. V naught is root 1764. That is 42. This is 42 meter per second. So what is this? This is the initial velocity of the ball, right? The next numerical. A car travels with a velocity of 20 meter per second. The driver applies the brakes and the car comes to rest in 10 seconds. Calculate the retardation. A car travels with a velocity of 20 meter per second. What is that? That is the initial velocity of the car. Okay. The driver applies the brakes, means, so what is the final velocity? So finally the car comes to rest, right? That means the final velocity is equal to 0. So time is 10 seconds. So we have to find out the retardation. So how do you find out retardation? So by using your first kinematic equation, that is V is equal to V naught plus AT. So AT is equal to V minus V naught. So A is equal to V minus V naught divided by T. So A is equal to, what is the value of V? V is equal to 0. V naught is 20, right? Divided by T. T value is 10. A is equal to minus 20 divided by 10. 0, 0 cancels here. A is equal to minus 2 meter per second square. This is negative. Negative acceleration means retardation. So your acceleration is negative, means this is retardation. Okay, retardation of the car. Retardation of the car is how much? That is minus 2 meter per second square, right? Okay, so thank you.